Hi there, everybody. Well, as you probably know, I am on campus today, so we are going to give you your lesson on screencast. You should be taking notes. I had a walkthrough activity on Jamboard with yesterday's group, but today we are just going to go through and explore it. We are solving linear systems. And a linear system is more than just a linear equation. We're going to solve it by graphing. So you can see here a linear system, a system of linear equations is called a linear system. It has two or more linear equations that have the same variables. The solution, this is important, the solution of a system of linear equations with two variables is any ordered pair, that's x comma y, that satisfies all of the equations in the system. So let's look at this. It says, describe the relationship between the two lines. How could we describe this relationship? Well, some of the answers that we got from the other groups. One has a positive slope, one has a negative slope. That's true, right? But the relationship between them, one way we could talk about it is they cross each other, right? Or in mathematical terms, they intersect. Okay. What do you know about every point on the graph on a linear equation? Right? If we were to take a linear equation and we were to look at every point, right? It has an x and a y, right? And together, all of the points form a line. Right? So, and then how many solutions does a system of two equations have if the graphs of the two equations intersect at exactly one point? So, right, a solution is all of the pairs that satisfy all of the equations. So where do we have a coordinate that would satisfy the equation for this line here and for this line here? It is at this point, right? This point right here is the solution, right? So how many solutions? One. What is it? It's where they intersect, because that spot is good for both equations, okay? So now let's look at another one. Let's talk about some special lines. This line here is black. What you can't see is that underneath it, there is another one, right? This is actually two lines, right? Maybe it's y equals x minus 2, and maybe it's also y minus 2 equals x minus 4. These two lines are the same, look to be the same, right? So what's the relationship between the two lines that coincide, right? They are the same. How many solutions does a system have if the graphs of the two lines intersect at infinitely many points? How many spots on these two lines, which are the same, have the same x and y? That would be an infinite number, infinite amount of solutions. Two lines that have the same slope. In this case, the slope is x, right? Same slope, different, whoops. same intercept means same line. How about this one? What's the relationship between these two lines? We could say they have the same slope. They have different intercepts, x and y. Okay. And by definition, two lines that have the same slope and different intercepts are called parallel. How many solutions do these have? How many points are on both of these lines? Hopefully, you know that's 0, okay? So, those are the types of linear systems that we're gonna look at. So now you need to understand this, and you should write down this vocabulary. A consistent system is a system with at least one solution. So, if we look up here, is this one consistent? Does it have at least one solution? No, it has 0 solutions. Is this consistent? It is consistent because it has at least one. It has an infinite amount. Infinity is more than one. And this is also consistent because it has one. Okay? So, a consistent system has at least one solution. They can either be independent or dependent. And independent has exactly one. So that means the lines intersect at exactly one point. A dependent system has infinitely many solutions. That has two coincident lines or the same line. So this one is consistent dependent. And this one is consistent independent. Okay, you need to know that. Okay, so what's this one? Well, let's look here. A system that has no solution is an inconsistent system. So this one is inconsistent. Okay. So now let's look. How do you solve a system of equations by graphing? Well, I will give you two equations. First step, find the intercepts for each equation plus a third point. Now, why a third point? Because if you make a mistake with your intercepts, it doesn't matter where I put two dots, I can always connect them, right? If I mess up on one, I won't know. But if I have 3 dots and they won't go in a straight line, somewhere I made a mistake, right? And then you got to figure out which of the 3 lines is the right one. So you go back and check. So we always want to have a third point to check. So let's look. 2x plus y equals 6. If y is 0, the x-intercept 2 times 3 equals 6. So 3, 0, that's that point. If x is 0, y equals 6. 0, 6, there's that point. And then say -1. When x is -1, 2 times -1 is -2, plus 8 equals 6. -1, 8. There's our 3 dots on that line. Now let's look on the next line. When y is 0, x is -3. So -3 comma 0 is right here. When x is 0, y is 3. So 0 comma 3 is right here. The third point, when x is 3, -3 plus what equals 3 plus 6 equals 3. So, or sorry, yeah, 3, 6 is right here. So there's our 3 points. Here's our pink line. Here's our green, oops, our green line. Where's our solution? Well, they cross right here. That's the solution. What is it? It is 1, comma 4. So now the last step is see if it fits. We're going to put a 1 in for x, a 4 in for y. 2 times 1 is 2, plus 4 is 6. 6 equals 6, yes. The opposite of 1 is -1, plus 4 equals 3. Yeah, 3 equals 3. So our solution checks out. Always put a third point. Always check your solution. Okay, let's look at this one. Find the intercepts for each equation plus a third point. So here's our two lines. When y is 0, 2 times 1 minus 2 equals 0. X is 1. When x is 0, y equals -2. When x is 3, 2 times 3 is 6. 6 minus 2 is 4. Let's put these in. 1, 0. 0, -2. 3, 4. Do these all line up? Let's look. Yes, they do. I'm going to put my arrows because you should always have arrows on your lines. I did not mark it wrong on the test, but I could have, and I will in the future. Let's try the other one. When y is 0, 6 times what is 18? 6 times 3 is 18. When x is 0, 3 times 6 is 18. 6 times 1 is 6. 18 minus 6 is 12. 3 times 4 is 12. So 3 comma 0, 0 comma 6, 1 comma 4. Are these all in a line? What did I do wrong? They're not all in a line. Ah, that's 0 comma 3. I put it at 0 comma 2. See how this works? If I hadn't done that, the intersection's going to be at the wrong spot. Try this again. That's better. Where do they intersect? Right here. What's that solution? 2, 2. So let's try it. 2, does 2 equal 2 times 2 minus 2? 2 times 2 is 4, minus 2 is 2. 2 equals 2. That checks. How about here? 2 plus 2 times 2. 2 times 2 is 4, plus 2 is 6. 6 equals 6. The solution is 2, 2. Okay? Now, next one, solving special linear systems. These are going to be either the consistent dependent, two lines that are the same, or inconsistent. Find the intercepts for each equation plus a third point. Okay, when y is 0, x is 1. 1 comma 0, these go by 2, so 1 comma 0 is right here. When x is 0, y is -2, that's right here. The third point is 2 comma 2, that's right here. They line up. Next one. X is -2, Y is 0. X is 0, Y is 4. X is 2, Y is 8. Okay, what do we know about these lines? They don't intersect. Let's check. They have a different intercept. What is the slope? We go up 1, 2 over 1, slope equals 2. What is the slope over here? Goes up 1, 2 over 1, slope equals 2. And I'm doing units, not numbers. If the slope is the same and the intercepts are different, they are parallel. It is an inconsistent system. Okay, let's look at this one. When y is 0, 3 times 1 minus 3 is 0. X is 1. When x is 0, y is -3. When x is 2, 3 times 2 is 6 minus 3 is 3. So let's plot it. 1, comma 0, -3, 0, comma -3, 3, 2, comma 3. Let's plot it. Oops. We're going to plot it with a blue line. We'll do the reverse here. All right, here when y is 0, x is 1. When x is 0, y is -3. And when x is 2, -6 plus 3 is -3. Notice these are different equations, right? We're going to go 1, comma 0 is here. -3 or 0, comma -3 is here. And 2, comma 3 is here. And then we will graph our line. What do you notice about the line? Hopefully you see these are the same. There are infinite solutions. They are the same line. That is a consistent and dependent system. Okay, so special lines. This one says you can estimate by graphing, right? If you have a graphing calculator, you graph them, you see where they cross, estimate the solution. I'm not going to go through this one. You can read through it on your own. All right, so the last part is, what do we do to interpret in a real world problem? You can solve real world problems with real world context by graphing equations. So let's look at this one. There's 2 bowling alleys. Rock and Bowl charges $2.75 per game plus $3 for shoe rental. $2.75 plus $3. Super Bowling charges $2.25 per game plus $3.50 for shoe rental. Okay. So what's the cost? How many games will the cost to bowl be about the same? Well, we're going to write a system of linear equations. So y equals 2.75 times x. X is the number of games, plus 3. That's for the first one. And then we have y equals 2.25 times x plus 350. All right, so let's graph them. When x is 0, here we'll start with this one. When x is 0, y is 3, right? You pay $3 for your shoe rental. When x is 1, y is 3 plus 275, that's 575. When x is 2, that's 4, 550, plus 3 is 850. Let's see if these line up. Now this one, I don't need to put an arrow on the left side. Oops. Because we can't go less than 0 on games played. So this, because of the context, is array. It only goes in one direction. Now let's look at the other. When x is 0, y is 350, right there. When x is 1, 350 plus 225 is 575. Oh, look at that. When x is 2, that's 450 plus 350 is 8. So now we have this one, and we're going to go like this. Oops, I was off on the beginning of that. Let's try that again. So where is the solution? Oops, did it again. The solution here is at 1, 575, right? The lines appear to intersect at $5.75. So the cost at both places will be the same for one game, bold, and that cost will be $5.75. Okay? I hope that makes sense. Now we can check using both equations. 275 times 1 plus 3 is 575. 225 times 1 plus 350 is 575. Okay, which bowling alley costs more if you bowl more than one game? Green, right? If you bowl 2 games, green's a little bit more. Every time it's going to get more. So maybe if you're bowling 1 game, you could go to the green one, but maybe if you're bowling more than 1, you want to go to the blue one. Okay, that's pretty much it for this homework. So I'm going to upload this document. If you need to refer to it, you can refer to it. But also, I'm going to upload your homework. And let me tell you about your homework. The homework that you are doing tonight has 6 problems. And what I want you to do is do all 6 problems. And then at the end, I want you to correct your answers. Okay? I have put on the second page the answer key. And then at the top of the first page, there's a space for you to input how many of the 6 you got correct. Okay? Be honest. I want to know if you know it. I'm not going to enter this one into this term's grades. Okay? Thank you so much. If you have any questions, reach out to me. I'll be available on Wednesday for fundamentals, tomorrow for fundamentals. Today, I'm not available. I have another class that I have to be at. Okay? Thank you. Have a great day.